Of course, yesterday we started gently distributed random variable. We are left with four lecture slide from yesterday. So I want us to go over that before we go into today's lecture. But what I can just tell you in summary about what we did yesterday, okay, is this. If I if I talk about discrete x and y, okay, so the probability of, if I have the probability of s equal to this, y equal to that, okay, can actually, we can actually figure this out. So, which is actually going to lead us to having, submission that, okay, situation where my focus is on marginal, where I'm only interested in getting just f of s. So, of course, I'm actually going to sum this over the variable that I'm not interested in. So, similarly, for this, I'm actually going to have this. Okay, now you're actually going to see this scenario is talking about situation where we I want to focus on just function of x or function of y, and with if x and y are discrete, we all just need to do what we're doing now. So where I'm focusing on s, I have to sum the joint over the variable that I'm not interested in. So now, and when I'm talking about in this situation now, if I'm talking about conditional, or maybe s given y, of course, I it's actually going to be this divided by that. And if I'm talking about y given s, is also going to be what I have here. Okay, and situation where x and y. Okay, if x and y are independent. Okay, so if x and y are independent, we're actually going to have these three conditions that actually going to play out. Okay, going to have that condition play out if they are independent. We're also going to have situation where this is going to be this. We have situation where this is going to be that. Now, if you take a look at this three scenario now, okay, this is a situation where x and y are independent. When x and y are independent, you can express the probability of the joint occurrence as a product of the marginal, or you actually have situation where conditional, s, the probability of s conditioning on y, if it give probability of s, of course, that's an independent too, or the probability of y given s, or equal to probability of y. So that's an independent too. Okay, so I'm now going to go into a situation where x and y are, are continuous. Okay, so continuous x and y. Okay, so for continuous x and y, okay, if I actually, I'm going to have f of x, y. Okay, I'm going to have f of x, y. And having f of x, y, x is going to have a state space, and y also going to have a state space. Okay, this is the joint. Okay, so now, when I do the integration of f of x, y, dx, the y, okay, the s, the y, if this is a to b and c to d, okay, also the same as having f of x, y, the y, the x c to d, a to b, all has to be equal to 1. Okay, the same thing is also going to play out here. Okay, situation where I'm summing over the state space. Okay, let me just do this. Let me say if I got p of xy, that's a joint. Okay, I'm trying to say this is a joint probability mass function, joint probability mass function. Okay, now summation p of x y. Okay, this also have to be equal to 1. So that is what is going to make the joint to be a valid. Okay, the joint also going to be valid under this category. And of course, if I want to generalize, okay, maybe I have integral dot 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 to integral f of x1 comma s2 dot 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 until I get to xn. I'm actually going to have the x1, the x2 dot 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 until I get to the xn. As also has to be equal to 1 in the case of a multivariate situation. Okay, so now if I want to get marginal as well in this category, okay, so f of s has to be integral f of x y, okay, the y, and of course you have to use the range of y in that situation, and f of y equal integral, f of x y ds a to b. Okay, now the moment you get that, okay, so you may want to find f of s given y. So it's going to be f of that divided by that. You may also want to find this right now also going to be that. Okay, these are the conditional, okay, the conditional functions, the conditional functions that we talk about. So if you want to talk about the issue of independence now, even here, okay, independence of x, of a continuous x and y. So f of x y equal f of s multiplied by f of y. So f of s given y equal f of s, and f of y given s equal f of y. So you need to, the moment you understand all of this, you're actually going to be fine. Okay, that's exactly what we're trying to say. Now, if you come to this example right now, okay, where they gave you this guy now, f of x y, okay, equal to that guy. Okay, now what I'm trying to say, okay, so you are giving f of x y to be 1 over 6 into x plus 4y. Okay, and we got this and we got this. Okay, now when you take a look at that, okay, you want to find f of s. So what you're gonna do is 1 over 6s plus 4y, the y, then you use the range of y 0 to 1. So what are you trying to use? Okay, you actually focus in on this, using this, okay, the y, okay, of, gonna use the range. Now I want to integrate with respect to y. Okay, x is gonna be seen, anything other than y will be seen as constant. Okay, so if I actually bring this guy out and I rewrite it to be this, okay, so right now, okay, integrating this guy, that's going to be xy, right? And this is going to be 4y squared over 2 from 0 to 1. Okay, like I said, the y is a random variable. Anything other than y is not a random variable. Okay, so now I'm going to have 1 over 6 into plugging 1 to where I have y. Okay, so I got this guy now plus, when you simplify that to, putting 1 squared, okay, minus when you now plug in 0. Okay, so when you plug in 0, okay, of course, you know that all these guys going to go to 0, and what you're going to have here is actually going to be 1 over 6x plus 2. And that was why you have 1 over 6x plus 2. Can you see that? I just derived that right now. So now, f of s equal 1 over 6 s plus 2, and the range of s still remains 0 and 2. And let me tell you this, if you really want to know whether this is correct, okay, when you perform an antiderivative on this over 0 to 2, it should give you 1. That's how to check. Okay, so similarly, you also, you can show this guy as well. Okay, similarly, you can actually show that guy, using what he said. You're going to integrate with respect to s, and the whole thing continue. And the moment you are able to do that, of course, you are set to find the conditional f of s given y. So the f of s given y is just going to be the ratio of that. So don't forget, you need to first find your f of y. Now I'm going to use that to divide that now. I'm just going to simplify. Then I'm done with the conditional function. Is there any question on that? Okay.